In this tutorial, we're going to talk about how you can use Xbasic to connect to a SQL database and manipulate the tables in the SQL database using the Xbasic programming language in Alpha 5. So before we get started, a few housekeeping items. You can follow along this presentation here that we're going to be using as the outline for the tutorial at this URL over here. So that's www.downloads.alphasoftware.com tutorials, and then using Xbasic with SQL tables.html. Then in order to follow along the tutorial, you'll need a connection string called Alpha Sports Xbasic that points to the alphasports.mdb file that ships with Alpha 5, or a version of Alpha Sports that you've exported to SQL Server. So in my case here, I've exported Alpha Sports to SQL Server. You can see I have a table there, a database called Alpha Sports 8 in SQL Server. So to make your connection, you'll go to the control panel, you'll go Tools, External Databases, Alpha DAO connection strings, and you'll create a connection string called Alpha Sports Xbasic that points to the alphasports.mdb file, which is in your program files, Alpha 5 v10 mdb files. Okay, so now that we have this sort of basic housekeeping out of the way, let's start the presentation. So basically there are methods in Alpha 5 and objects in Alpha 5 that make it very easy to read and update SQL data. There are really two different ways in which you can manipulate SQL data from within Alpha 5, and we'll mention both of them here, but we're going to focus though on the direct SQL commands in this presentation. So you can work with SQL data by creating an active link table in Alpha 5, or by executing SQL commands directly against the connection to the database. So an active link table is primarily of interest to people who are building desktop applications and who would like to build forms against SQL data. And basically an active link table is like an Alpha 5 native table. It's like a DBF table, excepting that it's populated on the fly with data from the SQL database. So let's just quickly demonstrate how an active link table works. So I'm going to go over to Alpha 5 right now, and I'm going to go here and say new active link table, and we'll create just a single active link table using our connection to Alpha Sports, and we'll choose the customer table. We'll choose all fields in the customer table. We'll just accept the default entries over here, and we'll give this table a name called active link customer. So that creates our active link table, and now here it is opened up in a standard Alpha 5 browse, and when we look in the Alpha 5 control panel, we can see there's a table there called active link customer, which behaves just like a normal Alpha 5 table. So I can go to this table over here, and I can modify the value there from, say, Talbot to Smith, and then if I go and look inside the SQL database, I'll see that that value has been changed. So let's pause now. So we've just changed the value in this record number 2 to record number 1 to Smith, and if we go now to SQL Server over here, and we basically do a quick query over here. So let's go here and say select top 1000 rows. We can see there's the change that we made, and if we go here and we make that into let's go here and edit this. So let's go and edit, say, Peabody, and make that into Jones. And then if we go back to Alpha 5 now and reopen this active link table, we'll see that the change has been made. So this table acts as though it were a DBF table, and you can do data entry against it using the standard techniques that you use for working with DBF tables. But behind the scenes, Alpha 5 is taking all the changes that you make to that table and persisting them against the SQL database. So active link tables are great if you want to go ahead and build a form or use the SQL table as though it were a native Alpha 5 table. But if you're building web applications, there's no need to go through active link tables. They're inefficient compared to going directly against the SQL database using Xbasic, and so that's what we're going to focus on in the rest of this tutorial. So when you use an active link table, the benefit of that is if you know how to manipulate DBF tables, which are the Alpha 5's native tables using Xbasic, then you're all set. So you can see here is the Xbasic commands for opening a native Alpha 5 table or an active link table and making a change to the data. So we can go ahead here and open up, say, our active link table and make a change, and then behind the scenes Alpha 5 will go and update the SQL table. So you didn't need to know any SQL to make a change to the table. So let's quickly go ahead here and demonstrate this code in the interactive window. So I'm going to go back now and paste the code in, and the only change that I'm going to make is that our active link table is called AL_customer. So we'll go ahead there and execute the first command, execute the second command, put the table into change mode, and let's go here and make this into John, and then do table end and then table close. And now let's go over to the SQL database over here and look at the result. So as you can see here, there's the first name, and it's now been changed to John. So clearly we were able to make a change against the SQL database without knowing any SQL at all, or without knowing anything about the Alpha DAO objects in Alpha 5. So now let's talk about the direct SQL command. So the benefit of the direct SQL commands is that it's very fast compared to active link tables, and it exposes all of the power of the SQL backend to you. So when you want to work with SQL data from Xbasic, you need to know about Alpha DAO. So Alpha DAO stands for Alpha Data Access Objects, and Alpha DAO basically is a collection of classes that make it very easy to work with SQL databases. And I'd like to contrast that with ADO, which is ActiveX Data Objects, which is Microsoft's technology for working with SQL databases. But I think that if you know ADO, you'll find that Alpha DAO is much easier to work with than ADO. So let's pause now and pick it up in the next video. In Alpha DAO, there's a large number of objects, and in this presentation we're going to really just focus on the three most important ones that you need to know about. So the first object that you need to know about is the connection object. This is the fundamental object that lets you actually connect to the SQL database, and then once you're connected to the database, lets you execute commands against the database. Those commands, of course, are SQL commands, which stands for Structured Query Language. The second object that you need to know about is the result set object, and the result set basically contains the data that is retrieved from the SQL database after you execute a command that selects data. And then the arguments object is an object that lets you, in effect, pass in variables to your SQL commands. So in order to understand the arguments object, let's take a look at a simple select statement here. You can see we're selecting all fields from the customer table where the state field is equal to Massachusetts. So in this particular case, the where clause, the filter argument, is explicitly stated here as Massachusetts. But you can also restate this SQL statement here using an argument. So an argument in Alpha DAO always starts with a colon. That's very important to know. So in this case, we've said that we want to select all customers from bill state region, all customers where bill state region equals, and then this argument value, and then we'll supply the value of this argument at the time that the command is executed. So in general, you should always try to use arguments in your SQL statements. In particular, in web applications, using arguments helps you prevent and prevent against SQL injection attacks. So let's take a look now at the connection object. So the first command that you'll execute in Xbasic when you want to work with SQL data is you'll create a new Xbasic object, which can be any name that you want, and you'll dim it as a connection object. So the connection object lives inside the SQL namespace, and so this is the syntax now for dimming a connection inside. So here's the connection object, and it's inside a namespace called SQL. So the syntax for indicating that an object is inside a namespace is the double colon. So you can think of a namespace in the same way that you say think of a folder on your hard drive. So you can basically, just like you can put files inside folders to organize where your files are, you can put objects inside namespaces to organize where the objects are. So in this case, we've created an object called CN from this class. The name CN is arbitrary. You could put, it could be any variable. So let's go to the interactive window right now, and I'm going to go here and say dim con as SQL : connection. So now at this point now, con is a SQL : connection object, and it has a whole bunch of methods. So if I go con dot, you can see I get to see all of the methods that this particular object has, but let's not worry about those methods right now. So the first thing that you do after you've created your connection object is you actually try to connect to a particular database, and in that case we'll be using the open method of the connection object, and we've already got a connection string called Alpha Sports Xbasic. So let's go back to the interactive window, and I'll type in open, and now if I just right click with my mouse on the connection string there, you'll see I get a pop-up window showing all of the connection strings that I've already built, or I can go and create a brand new connection string if I want using the connection string builder. So I'm going to go back now and right click over there and choose my named connection, and now basically when I press the enter key now, I'll execute the command and open the connection. So we've opened the connection, but you can see in this example over here we've stored the result of this method in a Xbasic variable called flag. So let's go back now and redo that. I'm going to go here and type in flag equals, and then let's take a look at what's inside flag, and you can see it basically says true. .t dot is the Xbasic syntax for a true value, and .f dot would be the Xbasic syntax for a false value. So this is one of the really nice consistent features of Alpha DAO. Every command that you execute returns either a true or a false, indicating whether the command succeeded or failed. And if it failed, then you can go and look up what the error message was, and we'll get to that a little later on. So now that we have an open connection to the database, we can now start executing commands against that database. So let's copy these three commands to the clipboard, go back to the interactive window now and paste them in, and I'll execute that command by pressing enter. I'll execute that command over there, and since our object is not called cn, we called it con, I'll do that, and now I'll go here and say flag, and I can see that flag is equal to true, which means that this command was executed successfully. So now that we've executed our command, we can actually look inside the call result object to see if there were any errors, what the error message was. So in this particular case, since there was no error, con.callResults.text is success. But now let's go and intentionally make an error. So what we're going to do is change the table name from customer to my customer, which will cause an error because there is no table called my customer. And let's see what happens. So I'm going to go there and say my customer, go there and type in flag. So now flag is equal to false, and now in order to see what the error was, I just re-execute that line over there, and you can see there's the error message telling me that that we have an invalid object name called my customer. So it's very important after every command that you execute to first of all store the result of the command in an Xbasic variable, and then if that variable is false, then check the error message by looking at the call result.text and then reporting that back to your users through some error reporting mechanism. So let's carry on now and talk about connection strings. So up until now we've spoken about using a named connection. You can see here when we connected to the database we used this syntax over here. So we had previously gone and created a named connection called Alpha Sports, and so this connection open used : name to indicate that we're using a named connection, not an explicit connection. So an explicit connection, as you can see over here, is always stored in curly brackets, and then has a whole bunch of name value parameters inside it. And you obviously build connections using the connection string builder, and then once you've built a connection, you can generally save it as a named connection. I would recommend that you always use named connections. You should never use ad hoc connections when you're building a real-world application. So let's pause now and pick it up in the next video. Okay, now that we know about connecting to the database and then checking to see whether the connection was successful by checking the callResult.text property, let's talk now about executing select commands. So let's copy this code to the clipboard and then execute it. And let's go over here and let me clear out that from the interactive window and go back and paste it in. So let's go here and execute that. Sorry. So that failed because we don't have an object called cn. So I'll just go here and say dim cn as SQL : connection. Execute that. Question mark flag. Execute our SQL command. Check the status again, and that's true. So now that we've successfully executed our SQL command, let's look at the data that's returned from this command. So one thing that I want to just quickly point out is that inside a SQL command, literal values are single quoted. So you can see here that the string Massachusetts has been single quoted, whereas the entire string, the whole SQL command itself, is an Xbasic string, so that's inside double quotes. Now in this case we used a literal value, but as I said earlier, we recommend that you always use arguments in your SQL commands. So let's take a look at how this SQL command here can be redone using arguments. So in order to use arguments, you first have to dim an Xbasic variable as a SQL arguments object, and the arguments object, just like the connection object, is inside the SQL namespace. So recall that we discussed earlier that a namespace is like a folder on a hard drive, and therefore in this case the arguments object is inside the SQL namespace. So the actual variable name that you use here is arbitrary. I could have used any name, so we happen to be using args. So let's copy that to the clipboard and go now and execute that. And so now args is a SQL : arguments object, and it too has a whole bunch of methods. So if I go args dot, I can see all of the methods that it has, and you can see that one of the methods that it has is the add method. So let's go back now, and what we're going to do is we're going to change our SQL so that instead of using a literal value over there, we use an argument over there instead. And so let's now go and create an argument called whatState and give it a value of Massachusetts. So I'm going to just copy that to the clipboard and then go to the interactive window and execute that. And so now I've created an argument called whatState, and if I were to go here and now say question mark args1 dot data, I can get Massachusetts. If I were to go here and say args dot argument number whatState, it tells me that whatState is the first argument in my list of arguments, which I already knew because at this point I only have one argument in the list. So let's pause now. So now let's take our SQL command and rewrite it to use arguments. So I'm going to go there and type in whatState. And now that I have this argument defined, let's execute our SQL command again. But if I were to execute it now without like this, I'm going to get an error, which we'll see. And the error is going to tell me that the SQL referenced an argument but no value was supplied. So if I go cn.callResult.text, you can see that there was a reference to a query, that the query had an argument but that no argument was provided. So the connection object's execute method takes a second optional argument called arguments. So I'm going to just pass in args over there, and now when I execute the command, basically it executes successfully because I've passed in the argument object which contains the value for that argument over there. So this is the general pattern for executing SQL commands that use arguments, which is you define your SQL, you specify the arguments, you create an argument object, you add the argument values, and then you execute the command. So arguments have a data type. So in this particular case, what state is a character value, and which is obviously true because we set its value to a character value over there. But arguments can have numeric, date, time, and short time, date time, and logical values. All of the data types that an Xbasic variable can have. So let's go and take a look at how you create arguments with different values. So you can see here we've basically, in this example, we've got an argument called what time, and we're using the Xbasic function now, which returns a value that is of a date time type. So that's the Xbasic T type. So what time is going to be a time argument. 23 is obviously just a number, so what number is going to be a numeric value. Date returns a Xbasic date variable, and so what date will be a date variable. And .t dot is an Xbasic logical, so is married will be a logical variable. So let's go ahead now and copy that to the clipboard and execute those commands. And if we go now, so now if we say question mark args2 dot data, you can see there's our time value, and if we were to go there and say type of, you can see it says time. Then args3 dot data is 23, and if I go there and say type of, that's going to be a numeric. So the way in which you specify the type of an argument is just by setting its value to a value of the particular type. Now arguments basically can also have a null value. So if you want to set an argument to have a null value, you use the set null method of the argument. So let's go back now and say args.set null, and I'll say salary comma n. So this is going to create a numeric argument, but with a value of null. So there we've gone ahead and done that. And now if I want to actually quickly see what all the argument values are, I can say args.xml, and that'll basically show me an XML representation of all of the arguments. So, and the last one, salary, you can see this is null, and that says true over there, whereas all of the other values are false. So let's pause now and pick it up in the next video. So the ability to actually dump out the arguments in an XML string is very useful if you want to persist the arguments and then reconstitute them later on. So for example, let's go here and just say x equals args.xml over there, and now let's create a brand new argument object, say dim args2 as SQL : arguments, and if I go args2 dot count, I get 0 because we haven't created any arguments yet. But now let's reconstitute args2 from this string x over here, which we previously persisted. So I'm going to go here and say args2.xml equals x, and now if I go question mark args2.count, I see that I have 6 arguments over there. So the ability to persist and reconstitute arguments by using the .xml property of the argument object is very useful. Okay, so now we've successfully executed our query against the SQL database. So now let's take a look at the second object that we spoke about earlier, which is the result set object. So the result set object is how you get at the data when a SQL command is successfully executed and returns results. So the result set is actually a property of the connection object. So let's go to the interactive window now, and you can see over here we successfully executed our SQL command. So now let's go and get a result set. So I'll say dim rs as SQL : result set. And like the connection and arguments object, the result set object is a member of the SQL : namespace. So now let's go here and say rs equals cn dot result set. So there you can see now we've set rs to the result set property of the connection object, and we now have a result set object which we can talk to actually read the data that we got back from the query. So first we're going to just quickly look at one of the utility functions in Alpha 5 for viewing data in a result set, and there's an Xbasic command called result set preview. So let's copy that to the clipboard and then go to the interactive window and paste in the command and now execute it. And you can see that Alpha 5 just brings up a quick dialog to show you the first 100 records in the result set. So now let's execute that command a second time, and now you see we see no records over here. So this points out a very important property of result sets. A result set is you can only read a result set in a forward only direction. You can never go backwards in the result set. And so the first time that we executed this command over here, Alpha 5 started reading the data in the result set and got to the end of the result set and then displayed the records in the pop-up dialog. And therefore at that point the record pointer was now at the end of the result set. So when I executed this command a second time, we were already at the end of the result set. There was no way that the result set could be repositioned to the beginning of the data. In order to make this command work a second time, I would need to re-execute the query and then reset the result set object back to the connection string.result set. And now when I do this, I can get to see the data again. So a very important point there, that result set you can only traverse them in a forward only direction. So let's pause and pick it up in the next video. So let's contrast the result set with, say, a table pointer for a DBF table, which can be traversed in both a forward and a reverse direction. So you can see here in this little code segment we are opening up a DBF table, and we're changing the first row to J, and then we go and we fetch the next record, then we fetch the next record. So now the record pointer is on the second record in the table, and then we go back and we fetch the first record. So we've traversed in a backwards direction. So with a DBF table you can move your record pointer forwards and backwards, but with a SQL result set you can only move your record pointer forwards. So now let's talk about some of the methods that the result set object has. So the first method that I'd like to discuss is the next row method, and the next row method has as its name implies, the purpose of just moving the record pointer in the result set to the next record. There is, of course, no previous row method because we've discussed that the result set is a forward-only object. Another thing I'd like to point out is that the result set doesn't tell you how many records are actually in the result set. So when you open up a result set, you actually don't know whether there are any records in the result set, or 1,000 records, or 1,000,000 records, or anything. You basically, you don't know any of that until you actually start moving through the result set. So in order to find out whether there are any records in a result set, one way would be to actually execute a count query before you execute your select to get your result set. So but an easier way to find out if there are any records, not to find out what the count is, but just simply to find out are there any records in the result set, is to use the next row method. So you can see over here in this little segment over here, we're executing a select statement, and our where clause is 1 equals 2, which of course is always false. So therefore, even though this command will execute successfully, there will be no records actually returned. So let's go now and copy this to the clipboard, and go ahead now and paste it in and execute these commands. So we execute the command, and if we look at flag, it's going to be true. Now we get our result set, and the first thing that we're going to do to find out are there any records in the result set is try to move to the next row. So before we do .next row, the record pointer is actually positioned on the is positioned before the first record in the result set. So now I'm going to go here and try to move, and this will in effect be trying to move to the first record in the result set. And so when I execute this command, basically I get false, which indicates that there were no records in the result set. So by immediately executing a .next row on a result set after you've executed your query, you can find out whether the result set has any records in it. You can't find out how many records the result set has, but you do know that there either are some records or that there are no records. So let's pause now and pick it up in the next video. So as we discussed previously, when the result set is first obtained, the record pointer is actually positioned before the first row in the record pointer. But when you execute any of the result set methods that read data from the result set, such as the .data or the .data is null method, then Alpha 5 in effect does an implicit next row to position you on the first record. So let's actually go ahead here and demonstrate that. So I'm going to go back here and remove the where clause now and execute this command and get my result set. So rs equals cn dot result set, and now I'm going to go here and say rs dot data 1. So notice that I have not done a .next row method. So what happens is, as soon as the .data method is executed to read the data from the first column, Alpha 5 does an implicit .next row. So if I go there, you can see it read and the value is 1, and now if I go, of course, rs dot next row and then read the next value, again, it's going to be value 2. So now let's do this again. I'm going to re-execute those commands, get the result set, and now before I read the data from the first row, I'm going to go here and say rs.next row. So the record pointer was positioned before the first record, so now we're positioned on the first record, and now when I do an rs.data, I still get 1. So basically the important point to remember here is that when you do a .data for the first time, Alpha 5 does an implicit next row if you haven't done an explicit next row yourself. So let's go back to our slides now and talk about the getting the actual count of the number of records. So as we mentioned, there is no property that will give you the count of the number of records in the result set. To find out how many records a particular query is going to return, you need to go and do a count query. So to do a count query, I would execute obviously a count query. So let's go here now and change this to count, and now execute our command, get our result set, and now read the data from the first column, and there is my result 61. So now I know that this result set, when I execute the result set like this, is going to have 61 rows of data in it. So now that we know how to get the result set, the next thing that we're going to talk about is looping through the result set, and this is obviously a very common pattern when you're using a programming language to work with SQL data. So you can see here we have a simple query again, which is select all records from the customer table where the state equals what state. We're setting the argument value to California, and then we're getting a result set. So let's go ahead now and copy this to the clipboard and execute those commands. So we've executed those commands over there, and now what we'd like to do is loop through all of the records in the result set. Actually, let's pause now and pick it up in the next video. So in order to loop through all the data, we're going to use an Xbasic while loop, and you can see that the very first command that we execute, that is, and this command is outside the while loop, is we set flag to rs.nextRow. So if there were no records in the result set, then flag would be false, but if there are records in the result set, then flag is going to be true. And now, after executing next row for the very first time, we're now positioned on the first record in the result set, not the second record, as we've discussed earlier. So our while loop basically is going to continue to loop while this variable flag is true. So in this particular loop, we're just simply capturing the last name data from the result set and adding it to an Xbasic variable called text, and then we go to the next row, and if there is a next row, then flag will be true and the loop will continue. But if flag is false, which it will be if we've reached the end of the result set, then flag will be false and our loop will terminate. So let's actually copy this code and paste it into an Xbasic script and see how it executes. So we'll go over here and let's create a brand new Alpha 5 script. We'll paste it in, and then at the end of this we'll just say show var of text. So we've pasted our command in, but I can see we're missing here dim cn as SQL : connection. So now that we've defined it, let's go ahead now and run the script, and you can see here's the results. So we've looped through the result set. There were 6 records in the result set, and we've created this string here by adding last name colon and then the name of the last name after each iteration of the loop. So just in summary, the basic pattern when you want to loop through a result set is you use a while loop with a flag variable. The flag variable is set to the result of the .nextRow method, and its initial value is set outside of the loop over here, so that if there were no records in the result set, flag would be false, and then we wouldn't go through the loop at all. But once we're in the loop, we after each iteration of the loop we do a .nextRow, which will return either true or false, and so when we get to the end of the result set, this will be false, and then we'll fall out of the while loop. So besides the next row method, obviously the result set has the .data method, which we've discussed previously. But in our previous discussions, we've been talking about using the column name as the argument of the data object, but you can also use the column number as the argument to the data object. You can also use data is null to tell whether a particular field value in the result set is null. So in this case, first name was equal to Michael, so data is null is false. But if this returned true, then the value in that particular column would be a null value. So now let's talk about some of the other methods that the result set object has, and we'll pause here and pick it up in the next video. So 4 very powerful functions of the result set object are toString, which dumps a result set out into a CRLF delimited string. And actually you can specify any delimiter, it doesn't have to be CRLF. There's the toDBF method, which creates a DBF file, toExcel, which creates an Excel file, and toJSON object syntax, which creates JSON data. So let's go ahead and look at these 4 methods in the interactive window. So I'm going to go here and just copy this code and go to the interactive window. So here we go, and toString returns basically all of the data in the result set. And you can see here that the toString method has several options. You can specify the number of rows that you want to copy, which row you want to start at, what column separator to use, and what row separator to use. So let's go ahead now and get another result set. And this time basically let's use the toDBF method. So I'm going to go here and say rs.toDBF, and I'll go here and create a file called and I'll put a question mark in front so I can see whether it was successful or not. So let's go ahead there and execute that. So it was successful. I'm going to go now and add that file to the control panel. So we've just added test.dbf to the control panel, there's test.dbf, and so there's our dbf file that we've created from the result set. And let's finally demonstrate the two JSON objects. So let's go again and execute our command, get the result set, and go here, rs.to JSON object syntax, and then press enter. And you can see there's basically the JSON syntax for the data. So getting data in JSON format is very useful in lots of web applications. So at this point we've been talking about doing select statements from your SQL database, but we haven't spoken about how to either insert, update, or delete records. So now we're going to move on to the insert, update, and delete SQL commands. So first let's just take a look at the basic syntax of an update statement. So here is an example of an update statement. You can see update, and then the name of the table that you want to update, then the keyword set, and then the list of fields that you want to update. So I want to go and set last name equals Ravens, comma, first name equals Selwyn, and then the where clause. The where clause is very important. If you leave the where clause out, what I would end up doing is updating every single row in the table, which in most cases would not be what you want. So in this case, our where clause says customer ID equals 1. So we're going to be just updating the first record in the table and setting the first name and last name to Selwyn. But as I mentioned earlier, you always would like to use arguments in your SQL statements in preference to using literal values. So here would be the exact same command, this time using arguments. So you can see that we've replaced this literal value over here with this argument called new last name, and then new first name, and then where customer ID equals old customer ID. So let's pause now and pick it up in the next video. So the update statement updates an existing record, then the insert statement adds a new record to a table. And so here's the basic syntax of an insert. So it's insert, and then into, which is just the keyword. Then customer is the name of the table that you want to insert into. Then here is a list of all of the fields that you'd like to insert values into. Then you have the values keyword followed by the actual values that you'd like to insert. And in this first case, in this first example, we're using literal values, but here is the preferred way of doing it using arguments. So everything is the same, excepting that instead of using the literal values here, we've got our arguments, new first name, new last name, and new company. And obviously there's no where clause associated with an insert statement. And then finally we have the delete statement, and here the syntax is delete from, and then the customer table names, where, and then customer ID equals 23. Now again, as in the update statement, the where clause is very important, because if you leave the where clause out, you'd go and delete every single record in the customer table. So again, using arguments, here is how you would express this SQL command here using arguments. So where customer ID equals, and then instead of the literal value 23, we have what customer ID. So when you execute any one of these statements, an update, an insert, or delete, you need to know, did it work? And did it work really is a two-stage process. The first question is, did the actual SQL command execute? So when you typed, connection object dot execute and then typed in the SQL command, did that return true or false? If it returned false, you know that it didn't execute. There was an error and the command never executed. But that doesn't actually tell you that the command was successful, because it might have executed, but there may have been no rows affected, or the insert might have failed for whatever reason. So as soon as you execute the command, you can then go to the call result and look at the rows affected property to see how many rows were affected by that command. So let's go ahead now and copy this to the clipboard, and let's paste that in. And so you can see here we're doing an update statement, and let's go now and set our argument values. There's new first name, new last name, and now we're going to go ahead and execute, and that tells us true. So that tells us that this command executed without any errors, but it doesn't tell us that if in fact the command was successful. We don't know yet whether any records were actually updated in the database. So now let's go and look at the call result.rows affected, and you can see here that that is going to return a value of 1. But now if I go here and let's change this argument value to some value that I know does not exist, and now I go ahead and execute that, basically in that case it returns false, but in other cases it might return true. And if I go and look now at rows affected, you can see that rows affected is 0. So it's very important after an update, insert, or delete to check the rows affected property of the connection object. So we'll pause now and pick it up in the next video. Now, in the case of an insert statement, in many cases you'll be inserting into tables that have an order increment value as the primary key, and it's going to be very important for you to know what value was assigned to the primary key when the insert statement executed. So in order to find out what the value of an order increment field is after an insert statement has executed, we use the connection object's last inserted identity property. So let's go ahead now and do an insert into the customer table. We're going to insert a new record into the table. So let's go ahead now and run our SQL. So here's our SQL insert command, and we're going to go and set first name to J, Talbot Alpha, and then we're going to go ahead now and execute. So you can see that return true. And now if we go look at last inserted identity, that returns 62. So that tells us that the primary key of the record that was just inserted has a value of 62, and of course rows affected should be 1, which it is. So so now we've discussed very simple update, insert, and delete statements, and of course writing the SQL statements can be tricky. Obviously there's a lot of documentation on writing SQL statements that you can find on the internet, but you can also use Alpha 5 to actually show you how to write SQL statements. And one very easy way to have Alpha 5 show you the SQL that it's executing behind the scenes is to go into, say, the grid component and turn on this show update commands property, and when you do that, Alpha 5 will show you the insert, updates, and delete statements that it actually executed. You can also go to the grid components on grid execute property and set the query echo property to true, and when you do that, then whenever you do a select statement that has a where clause or an order by clause, Alpha 5 will actually show you what the SQL command is that just got executed. So let's go ahead now and actually try that out. So I'm going to go here and build a very simple grid. And I'll choose an updatable SQL grid using my Alpha Sports Xbasic connection on the customer table. Go in and put in some fields, and then choose a search part, and I'll go there and choose and then let's go to our update settings and turn on show update commands, and then let's go to our events and on grid execute, and let's just save this as grid 1. So let's pause now and pick it up in the next video. So let's go to working preview, and I'll go there and do a sort. You can see now that we do order by first name. If I sort again, now it's order by first name descending. Now let's go here and type in, say, Massachusetts, and then do a search, and you can see now there's my my where clause now is where bill state region is like, and there's my argument bill state region 1, and you can see there's my argument value is percent MA% because Alpha 5 is been set to do a wildcard. But if we go here and change our, say, properties and change our search style from 2, which is contained in, to 1, which is an exact match, then we'll see now if I go here and type in, say, MA, NY, CA, then you can see there's our where clause is where bill state region equals the first argument, or the second argument, or the third argument, and there are our 3 argument values. So now let's go and actually do an update. So let's go here and type in Alpha Software, and then do a commit, and now look down over here and you can see there's our update statement. So update customer set company equal to the new company name, and the where clause here looks more complicated than anything that we've discussed before. You can see here's the where customer ID equals the primary key value 1, which is 2 over there. You can see that's the primary key over there. So the first part of the where clause looks pretty understandable, but then you can see the where clause continues with company equals old company, or company is null and old company is null. And basically this is how the update statement does optimistic record locking, because if some other user happened to change this record after we began editing but before we saved, then the old company wouldn't match the original company, and the update would fail. So this is in fact how the optimistic record locking is done. If I were to go back to design mode and go here, and if I were to go here and turn off check for write conflicts, and go back to working preview, and let's go here and make a change there and commit the record, you'll see that we end up with a much simpler where clause now. The where clause only involves the primary key value. So using the grid component, you can really learn a lot about how the SQL commands are written by turning on the show update property and setting the query echo to true. Now to write select statements, you can just use the query builder in Alpha 5 and it'll write the select statement for you. So You can see here to use the query builder, you just go in and you choose the tables that you want. So let's go there and choose, say, invoice header and the customer table. Join the two together on customer ID, and you can see Alpha 5 has written the SQL statement for you over there to join those two tables together. So you really don't have to write select statements yourself. You can use the query builder at all times, and you can learn a lot about update, delete, and insert statements by just turning on the trace feature in the grid component. So let's pause now.